Greetings, learners. Welcome to another session. In this session, we'll be looking at surds and exponents. So, we are given question 2 here, where we are asked to simplify fully without using a calculator. So, if we can check here, we have an expression which is a fraction here. So, in order for us to factorize or to simplify this fully, we need to make sure that we find the common factor on our numerator and also here on our denominator so that we can simplify this uh, fraction fully. Okay, let me try to write 2.1 here. Okay, this is 2.1. We have 3 to the power m plus 4 and then minus 6, which is 3 multiplied by 3 to the power m plus 1, all divided by what? 7 multiplied by 3 to the power m plus 2. Okay, so what do? You check the common factor here. We can see that 3 is common here, also here and here. So that's the common factor. So the only thing that uh, makes 3 complicated to take the common factor, what you can see here, you see that here is 3 to the power m plus 4, and then here is 3 to the power m plus 1, and then here is 3 to the power m plus 2. So what you do, you check which 3 has the lowest exponent. So we can see this one. This one it has the lowest exponent. So we need to rewrite 3 in terms of 3 to the power m plus 1. So if you can check the first one here, we have 3 to the power m plus 4. So how can we rewrite it to this form of 3 to the power m plus 1? We know that this can be written as 3 to the power m plus 1. And then we need to multiply 3 by 3. We need to multiply 3 to the power m plus 1 by what? By 3 to the power 3. Why? Because the rule of exponents, when you multiply numbers of the same base, you add the exponents. So you'll have 3 to the power m plus 4. And then here you have 6, right? 3 to the power m plus 1. It's perfect. We leave it like that. And then we divide by 7. And then here, 3 to the power m plus 2. How can we rewrite it to be 3 to the power m plus 1? We know we can write as 3 to the power m plus 1 multiplied by 1, 3 to the power 1, right? Because when we multiply this, remember we add the exponents again. So it will be 3 to the power m plus 1, which is 2 here. So it can be we can rewrite it into this form here. Okay, now we can find the common factor. We see here we have this one, 3 to the power m plus 1 here. Also here we have 3 to the power m plus 1. And here we have 3 to the power m plus 1, right? So let's take out the common factor. So our numerator will have 3 to the power m plus 1. And then we'll have 3 to the power 3. What is 3 to the power 3? 3 to the power 3 is what is 27. And then we have minus 6, right? Remember, we also take this one out. And then we have what? 3 to the power m plus 1. Multiplied by what? Multiplied by 7 times 3. What is 7 times 3? 7 times 3 is 21, right? This will cancel. We can see is 3 to the power m plus 1 divided by 3 to the power m plus 1. So it will cancel. And then here 27 minus 6. 27 minus 6, what do we have? We have 21. So it will be 21 divided by 21, which is what? Which is 1, right? So your final answer is 1. Okay. So Coming to 2.2, okay, 2.2, we need to simplify, or we need to solve for x without using a calculator. So what do we have? We have 2.2.1, right? So 2.2.1, what do we have? We have x to the power negative 3 divided by 4, right? This will equal to 8, right? So how can we solve x, or how can we solve for x here? The only problem that we see here is this exponent, which is negative 3 divided by 4. That's what makes this equation here to be difficult to solve for x. So we need to get rid of this exponent here, right? In order for us to solve for x. How do we get rid of this exponent? We know that 3 to the power negative 3 divided by 4. Okay, how can we get rid of negative 3 divided by 4? We need to multiply by what? The reciprocal of this, right? So we can multiply by negative 4 divided by 3, right? Such that this will cancel, this will cancel, right? We are left with 1 here, right? And then all equal to 8. Remember what we do on our left hand side. Since we multiply by negative 3, 4 divided by 3, we also have to multiply by this exponent here. It has to be what? Negative 4 divided by 3. So it has to be consistent. What we do on our left hand side, we must do on our right hand side. So here we'll be left with what? With x to the power 1, which is x. And then here we know that 8 can be written as what? Can be written as 2 to the power 3. And then 2 to the power 3. Remember, we're multiplying our exponents here. We multiply by negative uh, 4 divided by 3, right? We can simply see these 3's will cancel, and then we're left with 2 to the power negative 4, right? What is 2 to the power negative 4? We know that is 1 divided by 2 to the power 4. And then 2 to the power 4, we know that is what? Is 16. So our final answer is 1 divided by 16. Okay. And then moving forward to 2.2.2. Okay. So 2.2.2. Okay. We have what? We have 4 to the power x minus 2 to the power x, all equal to 2. Okay. We need to solve for x here without using the calculator. Okay. So how do we need to, okay, how can we rewrite 4 to the power x in terms of exponents such that we have the same basis? We can rewrite 4 as what? As 2 to the power 2, right? Okay, so we must not forget our x here. And then we'll have minus 2 to the power x, all equal to 2, right? So we know that these can be written as what? As 2 to the power 2x, right? Minus 2 to the power x minus 2, all will equal to 0, right? So it's very important to note that this, right, 2 to the power x here, you can take you can you can take 2 to the power x, or 2 to the power x as x. You can take it as x, or you can, okay, you can factorize this. You know the factors for 2 to the power 2x. What are the factors of 2 to the power 2x? We know we have 2 to the power x, right? And 2 to the power x. These are the factors of 2x. And then we have the factors of what? Of negative 2, right? So what are the factors of negative 2, right? So we know that we'll have what? a negative and a positive because we have this negative number here, right? So we can have x plus 1. I mean, we can have 2x plus 2 to the power x plus 1 or 2 to the power x minus 2. Okay, so we can confirm if these factors are correct. So 2 to the power x multiplied by 2 to the power x, we have 2 to the power 2x, and then 2 to the power x multiplied by negative 2, we have negative 2 to the power 2 to the power x, and then here 1 to the power 2x, we have positive 1 to the power 2x minus 2 multiplied by positive 1, we have what? Negative 2. So we can confirm that. Let's confirm. 2 to the power x multiplied by 2 to the power x, we have 2 to the power 2x, and then 2 to the power x multiplied by negative 2, we have negative 2x, 2 to the power x, and then 1 multiplied by 2x, what do we have? We have positive 2x, right? And then 1 multiplied by negative 2, we have what? We have negative 2. So we can see that negative 2 to the power 2x, 2 to the power x plus 2x, we can see here we'll have negative 2x, right? We'll have negative 2x here, and then here is the same, here is the same. So the factors are correct. Okay, so what do we do? We need to equate now. 2 to the power x plus 1 equal to 0, or 2 to the power x minus 2 will equal to 0, right? And then what do we have here? We have 2 to the power x equal to negative 1, or 2 to the power x equal to 2. So if we can check here, 2 to the power x equal to negative 1, this will not be true. Why? Because we know that 2 to the power x is the exponential graph, which always cuts at 1, where y equal to 1 here. Okay, and then the asymptote here we know is the x-axis. X-axis is asymptote. So there's no way that 2 to the power x, this function here, will approach what? Will approach negative 1 here, where y equals to negative 1. We can see that this will not exist. But this one will exist, this one. It will exist because what? We have 2 to the power x equal to what? To 2, right? We know if we have numbers of the same base equaling each other, right? Their exponents has to be equal. So x will equal to what? X will equal to 1. Okay? Moving forward. Okay? So for the next one, we have 2.3. 2.3, we have x equal to 3 square root of a divided by square root of 2, and then we have y equals to 4 plus square root of a. Okay, and then square root of 2. Okay, so they just want you to determine why x plus y squared will equal 2, right? So we know our value of x. Our value of x is what? Is 3 minus square root of a divided by square root of 2, and then plus our y. Our y is what? Is 4 plus square root of a divided by square root of 2. So we need to square this, okay? With our BODMAS rule, we know that we have to solve what's inside the brackets. So brackets first according to BODMAS. Okay. So we have the LCD of square root of 2, right? Okay, and then square root of 2 and divided by square root of 2 is what? Is 1. 1 multiplied by the numerator here is the numerator here, which is 3 minus square root of a. And then 1 divided by square root of 2 divided by square root of 2, we can see is 1. 1 multiplied by the numerator here. We have the numerator, which is 4, plus square root of a. Okay, and then solving this, we can see we have a negative square root of a and then square root of a. They will cancel each other. We have 3 plus 4, which is what? Which is 7. So we have 7 divided by square root of 2. Let's not forget that we are squaring everything, right? So what we need to do here, it's 7 squared. Remember, when you square a fraction, you square a numerator and square a denominator. So a numerator 7 squared is 49 divided by square root of 2 square is what? Is 2, right? So we have 49 divided by 2. So what do we have? We can write this in a mixed fraction, or we can find the decimal number of this, right? So this, it will be what? It will be 24. Okay, 1 uh 2, right? So it will be 24 1 over 2, right? Okay, and then moving forward, we have to show that the left hand side here, this expression here, equals to the right hand side here, right? So how can we do that? We need to write this. This is our 2.4. Okay, 2.4. Okay, so if we check our left hand side, what do we have? We have 12. Okay, let me write it properly. Okay, we have the 12th root of 10 multiplied by the 6th root of 640 multiplied by the 4th root of 810 multiplied by the square root of 40, right? So we need to simplify this, but what we know that we have the smallest number here, which is 10. Can we write these all numbers here in terms of 10? Yes, we can. So let's write it in terms of 10. We have what? We have the 6th root of 64 multiplied by 10, and then the 4th root of 81 multiplied by 10, and what? The square root of 4 multiplied by 10, right? So we know here we have what? We have the 4th root of 10. Okay, when we write this, we know we have the 6th root of 64. Um, we can rewrite this. We know that 64 is the same as 2 to the power what? To the power 6. So 2 to the power 6, you can confirm with your calculator. 2 to the power 6, it's what? Is 64, right? So this will be 2. Okay. And then 81 can be written as what? As 2 to the power, as 3 to the power 4. 3 to the power 4. So the fourth root of 81 is what? Is 3. So remember, this is the fourth root of 10. And then here, the square root of 4 we know is 2, which is what? The square root of 10. So what you need to do here, you can multiply the um, coefficients here, which is 2 times 3 times 2. So we have what? We have 12, right? So we need to also times the numbers here in the square root, but we can rewrite these numbers in terms of what? In terms of exponent. We know that 10, fourth root of 10 is can be written as 10 divided to the power 1 over 4 multiplied by what? 10. This one to the power, the sixth root can be written as to the power 1 divided by 6. And then this one can be written as what? 10 to the power 1 divided by 4. Okay. And then this one, the last one, it's 10 to the power half. That's the square root. Okay. So what do? We apply the exponents laws. We know when we multiply numbers of the same base, we add the exponents. So we'll have 10 to the power 1 divided by 4 plus, we add the exponents, 1 divided by 6 plus 1 divided by 4 plus 1 divided by 2. Okay, so we can quickly confirm. Okay, everything is in 10. Okay, now we can just add these numbers here. So we have 12 and 10 to the power. We need to find the common factor, the LCD here, which is what? Which is 12. Okay, so 12 divided by 4, which is what? 3. We'll have 3 here. 3 times 1 is 3. And then here we'll have plus 2. And then here we'll have plus 3. And then here we'll have plus, which is uh, this will be 12, right? So this will be 12. Okay. It will be 6, sorry. Okay, so we need to also confirm here. From here, I need to fix the square root here. It was supposed to be 12 here. So it's 12. Instead of 4, it's 12. Sorry about that. This is 12. I made an error. It's supposed to be 12. Okay, we can restart here. Okay. So our LCD will be what? Will be 12 here. So 12 divided by 12 is what? Is 1. 1 multiplied by 1 is what? Is 1. So 6 divided by 12, 12 divided by 6 is what? Is 2. And then 4 to 12. So it's 3. And then these to 12 will be what? Will be 6. Right? And then what we need to do next is to add everything. So 1 plus 2 is what? Is 3. 3 plus 3 is 6. 6 plus 6 is 12, right? So we'll have what? We'll have 12 times 10 to the power 12 divided by 12, right? Which is 1. So we have 1, 2 times 10 to the power 1, which is what? Which is 120, right? Okay, so we can conclude that um, I don't have much space here, but you can say the left hand side will equal to the right hand side. So you have proved. So it's very important for you to make sure that you don't miss anything, because it's very easy to make a mistake or to miss something and get everything wrong. Okay, we have reached the end. We have come to the end of today's video. Please don't forget to like and subscribe so that you can be informed when the next video is uploaded. Thank you.